Students, in this video we will discuss about solution of exercise 1.4 from the chapter sets. So let us start with question number 6. If A is equal to 3, 5, 7, 9, 11, B is equal to 7, 9, 11, 13, C is equal to 11, 13, 15, and D is a set collection of 15 and 17, find A intersection B. This operator intersection means common part of two sets. Okay, this operator implies the common part between the sets. If you look at A set and B set, the common part between A and B is 7, 9 and 11, right? Therefore A intersection B will contain 7, 9 and 11, right? Now similarly for B intersection B, these two is B and C respectively, and the common part is 11, 13. 11 and 13 is common for both B and C. So B intersection C will be a set containing 11 and 13. Now next one, A intersection C intersection D. That means you have to find the common part between A, C and D. If we look at here, in between A and C, only 11 is common. Between A and C, only 11 is common. But this 11 does not belongs to D set, right? That means there does not exist any element which is common in A, C and D. So that's why this set will be equal with phi set or null set. Now A intersection C, A and C, the common part of A and C is only 11. So that's why A intersection C is a set containing one element 11. B intersection D, B and D. As you can see, there is nothing common between B and D. So B intersection D will be phi set. Now, this one, A intersection B union C. As you can see, this B union C is in first bracket. So first of all, you have to find B union C. This operator union means the collection of all elements in B and C. The element will be 7, 9, 11, 13 and 15. 11, 13 is common for B and C, but I have to write 11 and 13 only once in the union set. Okay, so this is B union C. Now A intersection B union C means the common element between A set and B union C set. If you compare A and B union C, the common is 7, 9 and 11, right? So A intersection B union C will be 7, 9 and 11. Okay, and this way you have to solve this part. Now A intersection D, the common between A and D is nothing, that's why it will be a null set. Now next is A intersection B union D. Again same. First of all, you have to find B union D. All the elements between A, all the elements of B and D, they are 7, 9, 11, 13, 15 and 17, right? Now A intersection B union D means common part between common element of A and B union D. The common is 7, 9, 11. Okay, so this set contains 7, 9 and 11. Done. Now next, this one. Here these two are in the first bracket. So first of all I will find A intersection B. The common part between A and B is 7, 9 and 11. So that's why A intersection B contains 7, 9 and 11. Now B union C. B union C means collection of all the element of B and C. This is B set, this is C set. All the elements will be 7, 9, 11, 13 and 15. Therefore, A union B intersection B union C is equal to the common part of these two sets, and the common part will be 7, 9 and 11. Okay, this will be the solution of 9. Clear? The common part is these three elements. Now next one, A union D intersection D union C. First of all, A union D, that means the collection of all the elements of A and D. It will be 3, 5, 7, 9, 11, 15, 17. Okay, and B union C is again all the element of B and C. It will be 7, 9, 11, 13 and 15. Now A union D intersection B union C is equal to common part of this set and this set. Okay, if you examine the common part, 7 is common, 9 is common, 11 is common. So it will be collection of 7, 9 and 11. In this way you have to solve part number 10. So all these justifications are given here. Okay, all these justifications are given here. So now we will discuss about question number 7. If A is equal to X, where X is a natural number, and B is equal to X, where X is an even number, C is a collection of odd number and D is the collection of prime number, then what will be these sets? Okay, so first of all, A is a collection of natural numbers, means A is a collection of 1, 2, 3, 4, 5, 6 and so on. Okay, now B is the collection of even numbers, means it will be the collection of 2, 4, 6, 8, 10, 12 and so on. Okay, C is the collection of odd numbers, means it is collection of 1, 3, 5, 7, 9, 11 and so on. And D is the collection of prime number, means D will contain 2, 3, 5, 7, 11, 13 and so on, all the prime numbers. Okay, now if you look at this A set and B set, you can see all the elements of B set contains in A set. 2 contains here, then 4 contains here, 6 contains here, 8 also contains here. That means you can say that B is a subset of A. Similarly, by the similar argument, C is also subset of A, because 1 belongs to here, 3 belongs to here, 5 belongs to here, 7 belongs to here. So again C is subset of A. Similarly for D, because all the prime numbers are natural number, that's why D is also subset of A. Okay, so you got B subset of A, C subset of A, D is also subset of A. Okay, and you know, if any set is subset of another set, if X is subset of Y, then X intersection Y will be the smaller set. Okay, x intersection y will be the smaller set, because y is the superset, x is the subset. This is x and this is y, so the common part is x. Okay, so x intersection y is the x set. Now we will look at first one, a intersection b. A is subset of b, that means a intersection b will be the smaller set b. A intersection c, since c is subset of a, intersection will be the smaller set c. Similarly, a intersection d, by here it will be d. B intersection c. Okay, b is the collection of even natural number, c is the collection of odd natural number. Okay, there is no natural number, there is not a single natural number which is odd and even both, right? B is the collection of B is the collection of even natural number, that is 2, 4, 6, 8, 10 and so on. And C is collection of odd, means 1, 3, 5, 7, 9, 11 and so on. So you can see there is nothing common between B and C. So that's why B intersection C will be phi set. Now B intersection D. B is the collection of even natural number and D is the collection of prime number such as 2, 3, 5, 7, 9, sorry not 9, 7, 11, 13. Okay, so if you calculate B and D, if you look at B set and D set, the only even prime in B it is even and D contains prime. So when you are operating intersection between B and D, the characteristic of B intersection D will be even prime. The only natural number which is even prime is equal to 2. That means B intersection D contain 2. Okay, C is odd natural number, so C will contain 1, 3, 5, 7, 9 and so on, 11, 13 so on. D is collection of prime numbers, so it contains 2, 3, 5, 7, 11, 13 and so on. So the intersection between them, C intersection D, will contain x, where x is odd prime number. Okay, odd prime number, that means it will contain 3, 5, 7, 11, 13, 17 and so on, in this way. Now all these justifications are given here. A intersection B will be B set, A intersection C will be C set, A intersection D is D set, A intersection C, B intersection C is phi, B intersection D is singleton 2, C intersection D is odd prime number. Now question number 8, which of the following pairs of sets are disjoint? Disjoint means their intersection will be phi. Okay, two sets will be disjoint if they do not have any common element. Okay, first one is given as 1, 2, 3, 4. If you change this one in roster form, all the natural numbers between 4 to 6, it will be 4, 5 and 6. Okay, so suppose this is A set and this is B set. So if you operate intersection between them, only common will be 4. That means they are not disjoint set, because the intersection B is not equal to 5, it is not equal to phi set, that's why it is not a disjoint set. Now if you look at this and this one, as you can see, E is common. If you consider this set as C and this set as D, C intersection D will contain E. Again, not equal to null set, so it is not a disjoint set. Clear? Now the last one, x where x is even integer, here is x where x is odd integer. and considering this one is x, this one is y, so x will contain 2, 4, 6, 8, 10 and so on. Since it is even integer, the negative numbers will be also there, 0 will be also there, -2, -4, -6 and so on. And this set will contain 1, 3, 5, 7, 9 and so on. Again -1, -3, -5, -7, -9 and so on. So as you can see, there is nothing common between x and y, so that's why x intersection y will be phi set. So this pair of sets are disjoint because they do not have anything common. Okay, so all the expressions are given here. Now question number 9. If a, b, c and d are given, find a minus b, a minus c, a minus d and all these 12 parts. Okay, first of all, what do you mean by a minus b? A minus b means the collection of all the sets which belongs to a but does not belongs to b. Okay, a belongs to b means which belongs to a but does not belongs to b. If you look at this a and b, okay, this 3, 6, 9, 15, 18, 21 except 12, except this 12, all the element belongs to a but does not belongs to b. That's why a minus b will contain 3, 6, 9, 15, 18, 21. Okay, if you consider it in Venn diagram, suppose this is a and this one is b. Okay, this portion is considered as a minus b. This blue is a minus b. That is all the element which belongs to a but does not belongs to b. Similarly for a minus c, all the elements which belongs to a but does not belongs to c. As you can see, this 3, 6, 9. Okay, now we consider a and c, right? So 3, 9, 15, 18, 21. Okay, these 5 numbers belongs to a but does not belongs to c. So a minus c will be 3, 9, 15, 18, 21. Okay, in this way you have to solve a minus b, a minus c. Look at here, all these things are given here. Okay, clear? So in this way you have to solve these 12 parts. So this is all for today. Thank you.